Good afternoon, everyone. This is Smitty. I'm working on something again today. Today is going to be part 4 in my series of designing a Learn to Solder kit that I'm going to be bringing to a hardware hacking village that I'm running for my day job at the end of March. I got my boards back. I got my wonderful, beautiful purple boards from OSH Park. I love these boards so much. OSH Park does a great job, and my camera does a horrible job of autofocusing or selecting when to autofocus. Um, but OSH Park does a great job on their boards, and I'm super happy with them. And I will always, well, not, yeah. Anyway, I will recommend them without hesitation. Having said that, that pad right there and the square pad down there for the LED came without my holes in them. They missed a couple of drills. Luckily, I have a drill press, so I just went out into the garage, got the little tiniest drill that I could find, the drill bit that I could find, and pressed a couple of holes in there. Now, normally, when OSH Park does it, they plate through those holes so that if you solder to the top or to the bottom, it will connect to the other side. I was not able to do a plated through hole, but that's okay because, excuse me, that LED down there. You're going to put the component on this side, and then you'll end up soldering on that side, but it's the square pad which is tied to the ground plane on the back. So if I only solder the back side of that, that'll be okay. The front side of the pad is not actually connected to anything, so it doesn't need to be soldered to anything. That's a little bit different with this one here. It is also tied to the ground plane on the back. But those are that one there and that one there are the two pads that are used by the the 3 AAA battery pack on the back. That's what that big rectangle there is for. So there's going to be a battery pack that goes on the back of this. And so I'm going to need to solder to the back pad, because that's the one that's tied to the board or to the circuit. I'm going to need to solder to that back pad from the back side, but the component's going to be on there. So I'm soldering from the component side on this one, which will be a little bit of a bummer. But since it's only a prototype, I can get away with that. I will make sure that when the final production run comes through that we get that all taken care of with OSH Park. I'm still not sure whether it was my mistake or whether it was theirs. Their rendering on their webpage showed the holes on those two pads, so I'm leaning toward the theory that I didn't screw anything up, but I'm leaving it open, and hopefully they'll be able to come back and say, oops, yep, we screwed up while panelizing, we'll fix it next time. Or they say, nope, you screwed up, you need to do this differently, or whatever it is. So hopefully we'll figure that out. So that's what the boards look like when they're unpopulated. I wanted to spend some time assembling this on camera to post in this series, and I may still work on that, but I don't have a camera over there, which is where my soldering station is. So I went ahead and assembled a couple of these off camera, and you'll just have to, pretend there's a kind of montage here, but I'm covering up the LEDs, which are very glowy. How about I just unpower it? There we go. So that's what the board looks like when it's been assembled. I only put one of the two header rows on the outside, but we've got the WS2812 header here, the in-circuit programmer here, the FTDI serial programmer here. There's the IR receiver kind of bent up. You can see how it's, normally it mounts vertically, but I have it bent back so that when you wear it as a badge like this, it will be forward firing. Same with the LED down here. You got a couple of resistors there. One of those is a current limiter for the LED. The other one's the reset resistor. The two diodes that mix the power, one from the battery pack and one from the plus voltage that you get from either the FTDI or the ICSP header. That little blue thing there is the 16 megahertz oscillator. You can tell that it's got 3 pins. And then all of the little orange dots there are all the bypass caps that we talked about in the previous videos about how many we need. Technically, we probably only need one for this chip here, for the big CPU here, and then probably don't even need one for the IR receiver, but bypass all the things seems to be the mantra that we used. That capacitor right there is actually a reset capacitor. When you pull the DTR low on the FTDI header, it will send a reset pulse to the microprocessor that'll reset it and use it for doing programming from the Arduino software. And then, of course, up here are the two WS2812 LEDs up at the top. You'll notice that they're awfully close together. I didn't mean them to be that close together. You will also note that they're kind of off the board. The holes on that component outline are awfully small. I was barely able to get the LEDs to go through them, the LED pins to go through them. So one of the things that we're going to be doing today, one of the changes that I'm going to make is to modify that component a little bit. I'm going to make the pads a little bit longer this direction, you know, going back and forth like this, so it's a little easier to solder, because they're awfully narrow this direction. And then I'm also going to make the holes a little bit bigger so that the pins can go through them easier. It was kind of touch and go, shoving the LEDs through there, making sure not to bend any of the pins. And you'll also note that most LEDs have a little kind of bump in them where where the pins get broken off of a bigger sheet of metal. And I couldn't get it past that little bump, so they're kind of standing off the board a bit. One other thing I noticed after doing this is that to program it, since my serial programming cable, I don't have a full 6-pin FTDI header. I only have the 4-pin, the 4 separate pins like that, which is really convenient for hooking up to things like Raspberry Pis and whatnot, because it's not 6 pins in a row the way FTDI did it. So you have 4 individual pins and you can put them wherever you want to put them. The problem is that does not have the RTS signal that's used for resetting. So I have to reset these chips every time I program them, and I didn't put a reset button on it. So that's something I'm going to fix, is I'm going to put an outline on here for a reset button. Instead, what I've been doing is I have this green wire hooked up to a ground pin on the CPU, and then I just take this and put it into pin 1, which is down on the bottom, and that holds it into reset. And then when I'm ready to program it, I pull that out and hit Control U really quickly in Arduino, and that will upload my program. So I hold it in reset, and then I release the reset and upload very quickly, about half a second. It's doable. But it's kind of a hack, and so I'd rather just have a reset button on there. Well, really what I'd rather have is a 6-pin FTDI programming cable, so it'll take care of that for me, but I don't have that. So, and it's a good idea to have a reset button on your microcontroller anyway, because who knows what you might screw up or do with it. So those are the things that I want to do. I want to add a reset button. I'm looking at my notes over there. I want to share my notes. I want to add a reset button. I want to enlarge the pinholes for the WS2812 LEDs. I want to space the WS2812 LEDs a little farther apart. And then, oh yeah, I forgot to buy sockets. So that's something I need to add to my parts list. Why is my cursor offset? Okay, that's weird. So add a reset button, enlarge pinholes for the WS2812s, space the 2812 LEDs a little farther apart, and then I need to buy the 28-pin sockets for the CPU, because apparently I didn't do that, and so I just soldered my chips directly onto the board. But when you're doing a learn to solder kit, that's probably not a good idea for folks who have never done this sort of thing before. So those are the 3 things that I need to do. Otherwise, the circuit works great. Well, I have to confess, I haven't done anything with the I2C stuff down here yet, so that may still have a problem with it, but since it's not a primary part of the kit, I'm not going to worry about it too much. Oh, I also haven't done anything with this out here, but it's the WS2812 output. But those are, it's low-key enough. It's low complexity. It's very simple. It's just pins, so I'm not going to worry about that too much. I'm going to make those changes, and then I'm going to order another set of boards from OSH Park and get a version 1.1, maybe I'll call it a 1.0A, or I don't know what I'll do. Anyway, get a next version of the boards for the prototype, and make sure that they are correct before ordering 100 of them for the hardware hacking village that I'm going to do. Because I really want to make sure that I get those correct. I want to make sure I have a reset button and make sure those LEDs mount flush. Those are really the big things that I want to do. So that's what we're going to be doing today. Yeah, let's get started. Hopefully we'll have some folks join us in the Hangout. Oh, gotta move the screen so I can see it. There we go. Hopefully we'll have some folks join us in the Hangout today. But if not, then, I'll do what I do. We're going to start out in the schematic program. Move that down here. Okay. So the only change, the enlarging the pinholes and the placing the LEDs a little farther apart, those are all board changes. The only thing we need to do here is add a button to reset. So I'm going to go, do we already have a button? We do not already have a button on this board. So where are my buttons? I think, are they in device? Nope. All right. No. Rotate that. And doing a reset button is super duper easy. That's it. That's all I needed to do. It's a push button that ties the reset signal to ground, and you push the button and it pulls reset low, and that tells the CPU, stop what you're doing. And then when you release it, allows it allows the CPU to restart up again. The 10K pull-up resistor up here pulls the reset line up to high. So that is literally all we needed to do here. So save those changes. And let's go over and run the, oh, I got to annotate that. Yeah. Okay, annotate that. Then we're going to run, there we go. The CV blah, blah, blah. What's it called? CV PCB. That one, where we get to choose different outlines. Now, this is the only component we've added, so it's the only outline we need to pick. I'm going to stick with through hole. Okay, now I am going to share a different screen with you because this is the more interesting screen. These are all the different switches that they have in this library, and I don't want any of those slide switches. That is a pretty common switch, but it is the super simple single pole, single throw push buttons that are super cheap. That's it. That would be a good outline, but it's a little large, a little bit larger than what I want. So, now it's in the library down. I might have. This is my library of my components that I've created. Is that one for anybody who's watched my Enigma series? That is the single pole dual throw push button outline I created for the Enigma. There's the IR receiver, and there's my LED. Okay, we will have to figure that one out as well, but I don't have my push button in here. That is making me, oh, the one I'm thinking of, the single pole, that's it. That's the outline I was thinking of. That one. Okay, but I'm not doing surface mount for this kit. Oh, do I want to go through the trouble of building one, or am I just going to use the bigger buttons? Let's think. Where can I fit a bigger button on that? I was originally thinking of using one of the skinny ones and putting it right up here. It is a little awkward because I would have to tie the reset up here down to the reset pin down there, but I don't think there's a whole lot going on in the middle of the chip. We could probably arrange that. The bigger button wouldn't fit up there on that little skinny section, so I would have to find another place to put it. No, I really want it up in that little skinny section, so I'm going to have to go through the trouble of making a new outline. All right, that's okay. That's a good exercise. So let's get out of that app. I want to close that one. Hold on. PCB footprint editor. All right, and share that screen. All right. So we are going to select an active library and I don't know. I think I want to do this on my own library because I don't like modifying the inbuilt ones. So I've got my library loaded. New footprint. excuse me, footprint name. Single pull, single throw. Through hole. Okay. Hang on for a second. I've got a bunch of these buttons. Let me go grab one so I can. Oh, by the way, I found my calipers and I put them on my desk so that I wouldn't have to go looking for them again. But I'm going to go to my stockpile and grab a button so that I can measure it and figure out how to make it. I'll be right back. Buttons. Okay. Turn off the screen share. Okay, so that's my button. It is very wee. It is about half the size. I think it's 6 millimeters by 3 millimeters, but it's a very narrow single button, just two simple pins that, single pull, single throw, normally open button that you push it and it shorts the two pins together. And I think I can fit that button right up there somewhere. I think it'll fit pretty nicely between the board or the socket next to the chip and the edge of the board. And it will be, it'll kind of take up the same vertical space as my I2C header down here and the little bypass cap right there, but it'll be up near the top. And then I'll just need to find a way to get that reset signal from that top corner down to that corner there. That's fine. In theory, I might be able to fit it somewhere closer to the actual reset pin of the chip, or maybe down. Well, no, I can't do it down there because that's where the I2C stuff is. But I don't want to. I don't want it in the middle of the board because then it makes it hard to reach the button with all the components around it. So having the button near the outside edge makes the button a lot easier to reach when you do need to reset it. So I'm definitely going to put it up here, and I'll just find a way to get the track down there. Yeah. So let's go measure it. If you don't have one of these sets of calipers, little digital calipers, they are super cheap, super handy. I'm trying to find a way to where it doesn't glare the screen. There you go. On-off button. You zero it there. You can kind of move it all the way over there and hit the zero button. It's pretty good about staying calibrated. And then you can change between inches and millimeters with that button there. This is a super cheap one that I got from Harbor Freight, and it has been worth its weight in, maybe not gold, silver. It's been very handy. And even for like the $15-20 I spent on it, whatever it was super cheap. I'm going to be designing this in inches, not in millimeters. So I'm going to keep mine on inches because I'm that kind of American neophyte. And I'm going to measure the width. 0.14. Here, let's do it this way. 0.139 inches. I'll just call it 0.14. And that direction is 537. Am I reading that? 237. I'm reading it in a mirror image on the screen over there. So 237. So I'll just make that 250 and probably 150. So 150 by 250, because I do things in 25 mil increments. 150 by 250 will give me a superset and give me plenty of keep out space around it. The pin width is, oh, how did that get zeroed somewhere else? I'm gonna have to start over because that got zeroed somewhere. Yep, 138 and 237. So 150 by 250. Okay, so those numbers were correct. And then pin width is 0.04. So drill size I will make a little bit more precise. And it is 0.225 between the pins. 0.225 between the pins. Should probably be writing this down. 0.150 by 0.250 inches, and then 0.225 inch between pins, and 0.040 inch drill size, or pin size. Larger holes. Okay, so I got my notes. Let's go back and start working on a outline. Okay, let's start by plopping our pins down. So 2.25 separating them. So I'm going to go this way by 0.1. Actually, you know what? I'm going to do it this way. Plop, and we'll edit that. Pad number 1, through hole, shape circular, size 0.06. Well, what's the drill? The drill is 0.03. So let's make that a 0.05 or 5. There we go. Yeah, 7, 8, 9. 9 looks good. Maybe an 8, a 0.08 inch pad and a 0.045 inch drill hole so that I have plenty of space for those pins to go in. And that's pin 1 circular. Okay. And oops. I'm going to copy that one. No, I'm not. 0.225. There we go. What? Come on. 0.225. Yoink. Okay, so those are my pins. And except for the fact. Oh, bugger. What did I say it was? 238 width on 225. Yeah, I'm going to have to go to a smaller grid. Okay, we can do this. Then and a 140. I said a 140 width. Since I'm not doing 0.025s anymore, I'm doing 0.005s. I'm going to go ahead and do this to the right size. So where did I put those calipers? No, dadgummit. If you saw my desk, you'd understand the confusion. Oh, for the sake of Pete, I just put them down. Oh, there they are. My calipers were hiding. Again. All right. 0.038. So I'm going to go with 0.138. So I'm going to go with a 0.14. So from the center line, that's going to be up by 0.07. And 240. Math. $240, half of that would be $120. And no, I don't want half of that. I want 240 minus 225 is 15. So I need to split. Okay, so I'm going with 245 then. 245 minus 225 is 20. So I only need to go back by 0.10 or 0.010. All right. I swear this logic makes sense. If I do that, then so that's 225, and I go to 35.7 like that, and then go down to minus 7, 35.01, like that. Okay. So from here, that's 0.01, minus 0.01, and minus 0.07. So if I go down to that corner, minus 0.01. So if I add a 0.01, that's going to be 0.245. And 0.07 plus 0.07 is 0.14. So 0.245 and 0.14. Okay, so those are the correct dimensions. By the way, the numbers I'm looking at are down here. I don't know if you've been looking at those numbers too, but those are the. I haven't figured out how to get it to calculate the distance for me, but the absolute position of the cursor is what I've been looking at. Those are the numbers I've been looking at to try and figure out what the dimensions are. And then I'm going to just draw a button in the middle because I'm weird like that. So we'll start 1, 2. This one is completely arbitrary. So 1, 2. There we go. There's my button. Does that look good? I think it looks good. Let's move this right there. It doesn't matter because I don't use any of those, but that's my button. I'm going to save that. Button, single pole, single throw, through hole. And done. Let's go back to the schematic and cancel. And I'm going to run the CVPCB again. Let's go share that screen. Hello, by the way, like my shirt, Cookie Monster on a bender. It's one of my favorite shirts ever. Oh, hey, look, I've got a viewer. David Dunn, what about the traces? Will it clear? Digital caliper found here. Oh, okay. So, oh, it's Trooper. Hey, Trooper. So what about the traces? Will it clear? Are you asking about whether the pad width is going to be small enough to fit on that side of the board? Or are you asking something else? Something else? And then you included, that's what you're asking. Okay, we'll find out when I get to the board layout. Oh, you've actually joined. Why don't you unmute? Join us. Start talking. Very sick. Okay, well, maybe you won't. That's fine. Digital caliper found here. So I will make sure to include that link in the show notes on down below on YouTube there. The Harbor Freight 6-inch digital calipers. How much are they? Harbor Freight, they are $17.99. Okay, so like I said, not that much. The exact same caliper. Yep, they're pretty cool, pretty useful. Okay, so I'm back over here. Let's go there. Let's load my library. And did my switch make it in here? It did. Cha-ching. Save that. And then go back to my schematic, I think. Because I need to create another netlist. Cancel. Generate. Save my netlist. That was exciting, wasn't it? And where is it? There it is. Okay. Let's go that one and let's load our netlist. Read current netlist. Hey, look, a new component just showed up on the board. That is the wrong component. Whoops. What did I do? There we go. What did I do? Oh, haha, that is the wrong one. Button, that's the one. That's the one I just created. There we go. Save. Okay, I'm not going to bother changing screen share to the schematic because you don't actually ever get to see it anyway. So we'll go straight back to that one, even though I'm going to be working on a different screen for just a second. Nope, already did that one. Totally lied. Going over there, knock that off. Okay, and save my net list. Save. Then go here and read the net list. Read current net list. Yeah. Close. Better? Much better. Okay, so we'll put it up here somewhere. I don't know. How high do I want it? Do I want it like up there? No, I think I want it right about there. Looks pretty good to me. Okay. So I need to get from here around here and down over here without chopping off that board, because remember, that's our path between the top of the board and the bottom of the board. So I'm going to need to do this on both the top layer and the bottom layer to make sure I don't chop off my V plus, because I need to get a V plus there, or a VCC and a VCC there and there. So I can't lop off the bottom of the board by just bringing that down like that. What's my copper layer or the bottom layer look like? Similarly, I've got some grounds that I need to work around, like even that one down there. So I can't just take it on the bottom layer the entire way either. Unless I go like all the way around like that, which I think I can do. I'm going to go ahead and do that. All right, hang on. First off, wait, nope, cancel. We'll do that so I'm not trying to second guess that. Okay, we'll start there. What? No. Okay. Start DRC. Have I broken anything? Nope. And let's go take a look at our planes. Okay. So we no longer have a ground wrapped all the way around the I²C, but that's okay because we've got plenty of ground on that side. We haven't chopped that off. We haven't chopped that off because that's all a reasonably good connection around through. Well, it could be better, but it's not horrible. And rather than go all the way around there, I think no, I'll just leave it the way it is. I think that's okay. Let's look at the top layer. The body of the chip will help prevent accidental pushes. Well, that's true. That's a good point. So Tanker points out that by putting the switch close to the body, you'll not bump into it nearly as much. If I put it farther away, it would be easier to hit, but it would also be easier to accidentally bump. That's a good point. So, okay. Yeah, we haven't done anything to the top because the trace is entirely on the bottom. Okay. Cool. Now let me label that. Copy PCB text, put that there. Let's edit it. PCB text, and I'm going to make that left justified. I'm going to make that say reset that and move it to right there. And redraw because ugly. And I'm going to make that a thinner. I'm looking at my boards to see. No, I guess 0.1 doesn't look too bad. Okay, never mind. It looks kind of mushy here on KiCad, but once it gets printed onto the board, it's hard to tell because this camera doesn't focus for crap. There we go. Once it gets printed on the board, it's not nearly as bad. Oh, you had it. Why did you change? Did you assume that I wouldn't possibly be doing anything that close to the board, or to the camera? Trying to give it a wide surface. Oh well. Okay, so the text on there isn't so bad. So we'll leave the text like that. Okay, next thing I need to do, looking at my notes, I've added the reset button. So now I'm going to change the pad outline for the LEDs. So I'm going to open that back up to the component editor, footprint editor, which I've got right here. Okay, but I'm done with that one. Instead, I'm going to open footprint viewer, new footprint, load footprint from library. And I'm going to search by keyword. No, select by browser. There we go. Libraries. That one. All right. So you might remember in a previous episode that we created this library ourselves. I'm looking at that, and I think I want to make the circle a little bit bigger because I think the 8 millimeters is the size. Here, let me unshare. So you'll notice how the LEDs kind of have this base at the bottom. I think the 8 millimeters is that diameter up there, and then that diameter down there is a little bit wider. So again, calipers. I'm going to go back to millimeters on this one because I know these components are intentionally measured in millimeters. Sure enough, 7.79 on the wide part, or on the body part. And then it's kind of weird. 9.09 on the wide part on the bottom. So it adds another millimeter. So let's go ahead and make that circle a little bit bigger. Screen share, because it's what we do. So I'm going to edit that component, center point X, point Y, center X, item thickness, what? Inches. Math. I was told there would be no math. B, C, L, what is it? 25.4 and over 25.4 is going to be 0.354. Let's call it 0.36 inches, which is going to make this a 0.18 diameter. Okay, that made that a little bit bigger. Okay. Now let's move this right about there. We want it like there. That probably gets the point across, doesn't it? Okay. Next thing I'm going to do is I'm going to edit these. I am going to make the Y size 0.7, maybe 0.8 with 0.8, and I want the drill hole to be 3.0. Okay. It was 0.025, and I'm going to make it 0.03. Actually, you know what? Again, I have calipers, and I've got an LED. Let's measure it. Let's go back to inches because I'm stupid American, and I do everything in inches. And measuring this, 0.02 inches wide. And so 0.025 should have been okay, but it wasn't. So I'm going to make it a little bit bigger. I was measuring the flat side, not the diagonal. Let's measure the diagonal. 0.0235. So yeah, I'm going to go with 0.3. And then I'm going to try and measure that little snake eating a rat down at the base where these got stuck going into the board. 0.29. All right. I'm going to stick with a 0.3. You might have to force it past that part down to the bottom, but I think I'm okay with that. I'm going to stick with 0.03 because the pad is only 0.04 wide, and I don't want to make the pads much wider. Otherwise, you'll risk solder bridging. Okay. Okay, so 0.03 for the drill and 0.08 for the size Y. And I'm going to edit these and make the changes, the same changes everywhere else. 0.8. 3. And if you don't remember from my previous videos, unfortunately, the way Hangouts does screen share, it does not share the modals that pop up, and it doesn't list them as in the list of screens to share. So I can't actually show you anything that I do in the KiCad pop-up modals. But you've seen the results of it. So this is now up to 9mm wide. Even though it's an 8mm LED, the 8mm is a internal circle, and then the flange is 9mm wide. I also enlarged these drill holes a little bit, and I made the pads wider, so that we have a little bit more surface area to solder to. Because if I just make the drills bigger, then this little gap right here will be too narrow, and if I didn't make it wider here, it would just be very difficult to solder to. So I intentionally made those wider. Okay, so I'm happy with that. I'm going to save that, save those changes, and then, so I've enlarged that, and then the next thing to do is to space the LEDs a little bit farther apart. Okay, so I'm done with the component editor. Hello. And I'm going to go back to my board layout, and let's see here. How do I do this? Can I just load that? Read current net list. Will that load the new components in? No, it does not. Let me save my changes in case I screw this up. I'm going to delete these, maybe. There we go. And net list again. Yep, okay. Aha, and you'll notice that they overlap a little bit now that I've got the proper size in there. Those holes have an awful lot of space around them. The holes that we're going to use for lanyard mounting, right? On the board diagram, there's a big purple circle around there. I think it's a keep out zone. It's meant so that you don't put any components next to where you might put like a nut or a washer or something. We're not going to be doing that. The lanyards are all going to be out the top, so I can move these LEDs a little bit farther out and get them closer to those holes without any problem. So that's what I'm going to do. So none of it's on the top layer. It's all on the bottom layer. So I'm going to drag that there, and I'm going to drag that one there. And by dragging instead of moving, it will take the traces with it, which is something that we should be aware of. Oh, that one didn't drag. Oh, yes, it did. It just put an angle at it. Okay. I'm okay with that. Because that's still a 90. Okay. So let's do a DRC so we redo our ground planes. No, disconnected. Okay, let's look at our ground planes, or planes in general. So that's our ground. That looks good. So we've added our reset button, and that's tied to ground there, and the reset line goes all the way around, does not cut anything off to the reset. We have improved our LEDs. They are bigger. They are spaced farther apart. They got better holes. Let's look at the top layer. Yep, VCC tied to the plane. Those holes look good. I don't know. What are you thinking, Tanker? Did I miss anything? I didn't change any of the rest of it. Electrically, I've tested out the ICSP header, it works. The FTDI header, it works. I've tested out the LEDs, they work. I have not tested this, but that's pretty brain dead simple. Data out to a data pin here and VCC and ground, right? I mean, that's the only, there's nothing to test there. And 100 microfarads of capacitance to make sure that any noise generated on those LEDs don't show up to the rest of the board. My diodes work, although technically I guess I haven't tested the battery yet. But again, that's a pretty simple thing, hard to screw up. 470 is a value that I might have to decrease actually, because, which is a bummer because I just bought the resistors, but the IR isn't very bright, and I'm worried that it's not going to be seen. So I may want to change that to like a 220 or something that'll double the current through it. The 10K is fine. All those bypass caps are fine. The crystal works great. The spacing on the chip and the headers is great. Technically, I haven't tested the IR transmitter and receivers. I should probably write some code to test that before I order this to make sure all of that's going fine. Yeah. So that looks pretty good to me. Any other viewers got any other ideas of what to do? Give me a holler. Put them in the comments here on the YouTube, or send me a message on Twitter, which is where I do most of my social stuff. At Smitty Halibut is my Twitter account. That's where you can reach me. And let me know what you think. I've got some code I need to write, which I'm not going to do on YouTube before, so I can test out the IR stuff and make sure it's all correct before I order these boards. But I'm going to be doing that today, and then I hope to place this order because it takes about 2 weeks. It's a 2-week turnaround for new boards, and I need to have this stuff ready for in about 5 weeks. The event is in 7 weeks, and so I want to make darn sure that I have enough time for all of this stuff, the software, all the kitting. I need to put the kits together. I bought a bunch of components. Big box of stuff from Mauser. There are the CPUs, the microcontrollers, battery packs. Pin headers? What are these? Yeah, pin headers. These are from eBay, not Mauser. And a bunch of other random miscellaneous components. They're the electrolytics. The resistors are in there. I think the 16 megahertz crystal oscillators are in here somewhere. Can't see them, but they're in there. So I need to put all of those into anti-static bags. So you can tell that I've been putting parts together for this event for a couple weeks while I've been waiting for these boards to show up. So that's what I'm doing. I'm not going to write code on this stream. I will probably spend some time once I have a relatively final code going over what it is that I wrote, but the process of writing code is not nearly as interactive, and it's much more iterative than doing the hardware layout. So I'm not going to do that on the stream. I think that's, I mean, I'm surprised anybody watches these streams at all. And that just seems even more boring than what I want. But I will go over the code once I have a kind of a finalized thing, especially since I don't really know what it's going to do yet. I've got some ideas, but it's going to be a try something, look at it and say, well, that's kind of stupid, and then try something else, and well, it's a little bit better, or no, I like the first idea better, whatever. It's going to be much more iterative than this circuit board stuff is. The body of the chip will help. Oh no, shiny. There's always that one guy who will watch the stream, kind of like you, Tanker. Not to, you know, I don't honestly, this stream was an accident. I was not intending to make a YouTube channel, but I did a hangout to work on a board, and then all of a sudden when I was done, it said, boop, your hangout, your video is now available on YouTube. I'm like, really? Okay. And then I started getting some followers, which kind of scared me. So, but I'll keep going. If people are interested in watching it, I'll keep doing it. Far be it for me to judge. People watch people play video games, so who knows? If it makes you feel any better, my 3-year-old likes to sit here and watch too. Hi, 3-year-old. What's his name or her name? What's the kid's name? Isaac. Hi, Isaac. I'm Mark. Nice to meet you. Hopefully someday you can put your dad to shame on some of these circuits, and maybe you can make some awesome stuff too. And if it's something that interests you, you can do it, and it's going to be awesome. It's a lot of fun. You can make things. There are a few things in the world more satisfying than saying, I made that. And not just I put something together that somebody else designed, but this was my idea, and I put all those ideas together in a way, and I have a thing to show for it. My daughter just walked in the room. Would you like to say hi? Meow. You got to look up there. That's my daughter, Zoe. Say hello. Meow. So anyway, that's it. We're done for today anyway. I got some more testing I'm gonna do, and then I'm gonna place an order just like I did last time with OSH Park, and get another set of boards hopefully in a couple of weeks, and confirm that my changes worked. The reset button and the changes to the LEDs make it a little easier to assemble. And then I'm gonna be placing an order for 100 of them. So that'll be exciting. And I will let you all know how that goes. And when I have some working code, then I will I'll do a screen share and go over all the code that I wrote and what it does and why it does it that way and how I came to that thought. And we'll do that. All right. Thanks for watching. Throw your comments down here in the YouTube or hit me up on Twitter at Smitty Halibut, and we'll see you next time I'm working on something. Thanks a bunch. Storm.